You can also rationalize the denominator and convert it into rational form. So thus we can write sine 75 degree as root 3 plus 1 divided by 2 root 2. Tan 3x minus tan 2x minus tan x is equal to tan 3x tan 2x tan x. Hence we have proved the result. 1 root 2 cancels with the denominator. So we'll get root 2 cos x. So that is the right hand side value of the given trigonometric equation. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So previous sessions we have learned all the domain range of trigonometric functions, signs of trigonometric functions in different quadrants, also some of the trigonometric identities which helps us to solve a kind of problems in trigonometry. In today's session, we are going to take a few problems on trigonometric function. First one, find the value of sine 75 degree. So we know the standard values of sum of the angles of all 6 trigonometric functions. So here sine 75 degree is given. But I don't know the value of sine 75 degree because we have not learnt it as one of the standard angles. So that's why sine 75 degree can be written as sine 45 degree plus 30 degree. Now you can see here the given sine function is in the form of sine x plus y. So it's a compound angle and we know the identity of sine x plus y, that is sine x plus y can be written as sine x cos y plus cos x sin y. That is sine x cos y plus cos x sin y. Now using this identity, we can take x as 45 degree and y as 30 degree. So expanding this, we will get this as sine 45 degree cos 30 degree plus cos 45 degree sin 30 degree. We know the standard values of 45 degree and 30 degree in terms of sine and cos. That is sine 45 is 1 by root 2, cos 30 is root 3 by 2. Cos 45 is 1 by root 2 and sin 30 is 1 by 2. So we will get here root 3 divided by 2 root 2 plus 1 divided by 2 root 2. So therefore you will get the value as root 3 plus 1 divided by 2 root 2. You can also rationalize the denominator and convert it into rational form. So thus we can write sine 75 degree as root 3 plus 1 divided by 2 root 2. Next. Find the value of tan 15 degree. So tan 15 degree we have not learnt under the standard angles, but tan 15 degree can be written in the form of tan 45 degree minus 30 degree. Now this is in the form of your tan x minus y. We know that tan x minus y can be written as tan x minus tan y whole divided by 1 plus tan x tan y. Thus, we can write this in the form of tan 45 degree minus tan 30 degree whole divided by 1 plus tan 45 degree tan 30 degree. We know the value of tan 45 degree is 1 and tan 30 is 1 by root 3. So here it is again 1 plus 1 into 1 by root 3. So which is root 3 minus 1 by root 3 and here root 3, 1 into 1 is 1 here, so root 3 plus 1 divided by root 3. So root 3 get cancels. We will get the value as root 3 minus 1 divided by root 3 plus 1. So we can also rationalize the denominator. So thus we can take the value of tan 15 degree as root 3 minus 1 divided by root 3 plus 1. If you want to convert this into rational form, then you can just multiply the conjugate of root 3 plus 1, that is root 3 plus 1 as root 3 minus 1. Then you will get it as root 3 minus 1 whole square, which you can write it as 3 plus 1 minus 2 root 3 whole divided by, this is in the form of a plus b, a minus b, which can be written as a square minus b square. So you will get root 3 whole square as 3 minus 1. So you will get this as 4 minus 2 root 2 divided by 2, or I can write tan 15 degree as when you divide the numerator by 2, you will get the value as 2 minus root 2. So this is the value of tan 15 degree. So 1, we can just write it in the form of root 3 minus 1 by root 3 plus 1. And this is the rationalized form of tan 15 degree. Hence the value of tan 15 is 2 minus root 2. Next we have tan 3x, tan 2x, tan x is equal to tan 3x minus tan 2x minus tan x. So we need to prove the following trigonometric results here. So let me take tan 3x. So tan 3x can be expressed as tan 2x plus x. Now this is in the form of tan x plus y, which can be expressed as tan x plus tan y divided by 1 minus tan x tan y. So here you will get this as tan 2x plus tan x divided by 1 minus tan 2x into tan x. Now here I have tan 3x. Shift this denominator value towards your left hand side. Then it is tan 3x into 1, tan 3x minus tan 3x into tan 2x into tan x. That is tan 3x into tan 2x into tan x. And on your right hand side you have tan 2x plus tan x. Now let me shift this term towards your right hand side and all these terms towards your left hand side. Therefore, I will get tan 3x minus tan 2x minus tan x as tan 3x into tan 2x into tan x. Hence it is proved. So you can clearly see tan 3x minus tan 2x minus tan x is equal to tan 3x tan 2x tan x. Hence we have proved the result. Next, cos pi by 4 plus x plus cos pi by 4 minus x is equal to root 2 cos x. Now consider the left hand side of the equation. So I need to show that cos pi by 4 plus x and cos pi by 4 minus x is equal to root 2 cos x. So here I'll use the transformation formula cos x plus cos y. So what is cos x plus cos y? Cos x plus cos y is 2 cos x plus y by 2 cos x minus y by 2. So using that transformation formula, here this complete term you should take it as x and this complete term you should take it as y. So assume this as x and this is one term y. Now we have this in the form of cos x plus cos y. So we can write this as 2 cos of x plus y means our x is pi by 4 plus x plus y means this is our y term. So therefore it is pi by 4 minus x whole divided by 2. And cos x minus y form. So this is x term pi by 4 plus x minus y term. Minus pi by 4 minus x means minus pi by 4 minus of minus x become plus x whole divided by 2. So when you subtract minus pi by 4 minus x, then sign changes here. So it becomes minus pi by 4 plus x. Now here you can see it can be written as 2 cos x and minus x cancels. Pi by 4 plus pi by 4 is 2 times pi by 4. So 2 times pi by 4 by 2 becomes only pi by 4. Next here we have cos plus pi by 4 minus pi by 4 get cancels. X plus x is 2x, 2x by 2 is x. So therefore it is cos x now. What is the value of cos pi by 4? So cos pi by 4 is 1 by root 2 into cos x. We know that 2 can be written as root 2 into root 2. So 1 root 2 cancels with the denominator. So we'll get root 2 cos x. So that is the right hand side value of the given trigonometric equation. Hence proved. Next, tan pi by 4 plus x divided by tan pi by 4 minus x is equal to 1 plus tan x divided by 1 minus tan x whole square. So here I should use the form of tan x plus y and tan x minus y. So let me consider the left hand side of the equation. So this is tan pi by 4 plus x whole divided by tan pi by 4 minus x. Now for the numerator, I will use the formula of tan x plus y. So what is tan x plus y? Tan x plus tan y divided by 1 minus tan x tan y. So in the place of x you have pi by 4, in the place of y you have x. So just replacing the terms and constants here. So next we have here tan pi by 4 minus tan x whole divided by 1 plus tan pi by 4 tan x. We know the value of tan pi by 4 as 1. So wherever you have tan pi by 4, you can just write it as 1. So then you will get here 1 minus tan x, 1 plus tan x divided by 1 minus tan x. And here you will get 1 minus tan x divided by 1 plus tan x. So we have two fractions in the numerator and denominator. The denominator fraction can be taken in the form of a reciprocal. So we will get 1 plus tan x, 1 minus tan x into 1 plus tan x divided by 1 minus tan x. So thus numerator is 1 plus tan x whole square, denominator is 1 minus tan x whole square. Thus we can write this as 1 plus tan x divided by 1 minus tan x whole square. So that is RHS. Hence we proved. You can also take tan pi by 4 plus x as 1 plus tan x 1 minus tan x as one more identity, and tan pi by 4 minus x as 1 minus tan x by 1 plus tan x. Next question, cos pi plus x cos of minus x divided by sin pi minus x cos pi by 2 plus x. So clearly you can see here we have an allied angles. So let us draw xy plane. So we have here 0 or 2 pi, here pi by 2, here pi, and here 3 pi by 2. Now we know the rule that whenever a function, any trigonometric function is allied with pi by 2 and 3 pi by 2, function changes to its co-function. When it is allied with pi or 2 pi, function remains the same. And sign of the trigonometric function depend upon the 4 quadrants. So now here let us consider the left hand side, that is cos pi plus x cos of minus x divided by sin pi minus x and cos pi by 2 plus x. Now here cos pi plus x. So pi plus x means it comes in the denominator. Pi plus x means it comes in the third quadrant. And in the third quadrant, cos function is negative. So therefore, I can write this as minus cos x. And cos of negative angle is cos only. That's why it is cos x. Denominator we have sin pi minus x. So pi minus x means it comes in the second quadrant. And in the second quadrant, sign is positive. So therefore, this can be written as sin x. And cos pi by 2 plus x. So pi by 2 plus x means it comes in the second quadrant. So cos pi by 2 plus x means second quadrant cos function is negative. And since we have allied angle with pi by 2, cos should change to sin. So therefore it becomes sin x. So therefore here we will get it as minus cos square x divided by minus sin square x. So minus get cancelled. Cos by sin is cot. That's why this will become cot square x, which is RHS. So this is the problem on allied angle property. Next, cos 3 pi by 4 plus x minus cos 3 pi by 4 minus x is equal to root 2 sin x. So previously we have done this kind of problem. Let me take this complete thing as cos x and this complete thing as cos y. We know the equation or an identity that cos x minus cos y is minus 2 times sin x plus y by 2 and sin x minus y by 2. So using this transformation formula here, cos 3 pi by 4 plus x minus cos 3 pi by 4 minus x can be written as minus 2 times sin of x plus y, that is 3 pi by 4 plus x plus 3 pi by 4 minus x whole divided by 2 and sin x minus y. So x is 3 pi by 4 plus x minus x is minus of this becomes minus 3 pi by 4 plus x whole divided by 2. Now clearly you can see here in the first term here x and minus x cancels. We have 3 pi by 4 plus 3 pi by 4, 2 times 3 pi by 4. So 2 and 2 get cancels. We are left with sin 3 pi by 4. And here 3 pi by 4 minus 3 pi by 4 cancels. X plus x is 2x. 2x by 2 is sin x we will get. Now we doesn't know the standard value for 3 pi by 4, but I can write 3 pi by 4 as sin pi minus pi by 4. So pi minus pi by 4 is same as 3 pi by 4. So when I say pi minus pi by 4, so pi minus pi by 4 means, so this is our pi. Pi minus x means it comes in the second quadrant. In the second quadrant, sign is positive. Hence, sin pi minus x can be written as sin x only. That is why here, sin pi minus pi by 4 can be written as sin pi by 4 only. Now here we have sin x. So let me write sin x here. And here we have minus 2. Now what is the value of sin pi by 4? It is minus 2 and 1 by root 2. So cancelling we will get this as minus root 2 sin x. So this is the value. Next we have sin square 6x minus sin square 4x is equal to sin 2x sin 10x. Now consider the left hand side of the equation. We have this in the form of sin square 6x minus sin square 4x. So this can be written as sin 6x plus sin 4x and sin 6x minus sin 4x. Now this is in the form of a square minus b square, which can be expressed as a plus b, a minus b. Now using the transformation formula sin x plus sin y and sin x minus sin y. We know that sin x plus sin y is 2 sin x plus y by 2, that is 6x plus 4x by 2 cos x minus y by 2, that is 6x minus 4x by 2. So this is the first transformation formula, sin x plus sin y form. And here we can use a sin x minus sin y. Sin x minus sin y is 2 cos x plus y by 2, that is 6x plus 4x by 2 and sin 6x minus 4x by 2. Now let us solve this. We have here 2 sin 6x plus 4x is 10x, 10x by 2 is 5x. Here we have 2x by 2, so cos x. Next here we have 2 cos 5x and sin x. I can write this as rearranging the term 2 sin 5x cos 5x. And here I will write it as 2 sin x cos x. So using the multiple angle formula of sin 2x, we know that sin 2x is nothing but 2 sin x cos x. So if you have x here, then it should be written in the form of 2x. So therefore, in the place of x here, you have 5x. So therefore, this can be written as sin 10x. So for x, you have 2x. So therefore, for 5x, it is 2 into 5x sin 10x. Similarly, here 2 sin x cos x. 2 sin x cos x is nothing but sin 2x. So thus, this is sin 2x into sin 10x, which is RHS. So we have one more shortcut method to find the sin square 6x minus sin square 4x is equal to sin 2x into sin 2x. That is, we have a trigonometric formula, that is sin square x minus sin square y can be written as sin x plus y and sin x minus y. So this is the formula we can use here. So here in the place of x you have 6x, in the place of y you have 4x. So that's why this is in the form of sin square x minus sin square y. Hence the answer will be in the form of sin x plus y, sin x minus y. So here we can use sin x plus y means 6x plus 4x becomes sin 10x here, and 6x minus 4x becomes sin 2x here. So this is one shortcut method to get the answer easily. And this is the solution using transformation formula. Next, cos square 2x minus cos square 6x is equal to sin 4x sin 8x. So again, let me consider the left hand side here. So we have cos square 2x minus cos square 6x. So this can be written as cos 2x plus cos 6x and cos 2x minus cos 6x. So using cos x plus cos y form, we will get 2 cos x plus y by 2 and x minus y by 2. Next, let me use cos x minus cos y formula, that is minus 2 sin x plus y by 2, that is 2x plus 6x by 2 and sin 2x minus 6x by 2. So thus here we will get this as 2 cos 8x by 2 is 4x and minus 4x by 2 is cos of minus 2x. And here we'll get minus 2 sin 4x and sin of minus 4x by 2 is minus 2x. We know that cos of any negative angle is cos x, whereas sin of negative angle can be written as minus sin x. So that's why here we will get this as 2 cos 4x cos 2x, and here we will get minus 2 sin 4x minus sin 2x we will get. So that minus can be multiplied here, so it becomes plus 2. So this can be written as sin 2x. Now I will rearrange the terms as 2 sin 2x cos 2x and here 2 sin 4x cos 4x. Now again using the multiple angle formula, that is 2 sin x cos x can be written as sin 2x. So if you have x here, then here it should be in the form of 2x. So therefore here we have x as 2x, so this becomes sin 4x. 2 into 2x is 4x. And here we have x as 4x. So therefore this becomes 2 into 4x is 8x. Thus, this is the RHS of the given trigonometric identity. So that is cos square 2x minus cos square 6x can be written as sin 4x sin 8x. Now I have given you one identity, that is sin square x minus sin square y can be written as sin x plus y and sin x minus y. The same identity can be used for this also. We have here cos square 2x minus cos square 6x. So cos square can be converted in terms of sine as if you have cos square x, then you can write it as 1 minus sine square x. So here it can be written as 1 minus sine square 2x minus 1 minus sine square 6x. So thus you will get 1 minus sine square 2x minus 1 plus sine square 6x. So minus 1 plus 1 cancel. You will get this in the form of sine square 6x minus sine square 2x. Now this is in the form of sine square x, sine square y. So this is x, this is y now. Hence you can write it as sine x plus y, sine x minus y. So you will get this in the form of sine 6x plus 2x and sine 6x minus 2x. So that is equal to sine 8x and sine 4x. So this is another alternative method to find the solution or to show that LHS is equal to RHS. Next we have sine 2x plus 2 sine 4x plus sine 6x is equal to 4 cos square x sine 4x. So here I cannot apply the transformation formula for the first two terms. So let me apply the transformation formula. I will first take the term sine 6x, then I'll take sine 2x, then here I'll take 2 sine 4x. Now let me apply the transformation formula for the first two terms, that is in the form of sine x plus sine y. So by applying the transformation formula, here I can write this in the form of sine x plus sine y as 2 sine x plus y by 2, that is 6x plus 2x by 2 into cos x minus y by 2, that is 6 minus 2x by 2. And here we have 2 sine 4x. Now 2 sine 6x plus 2x is 8x, 8x by 2 is 4. 6x minus 2x is 4x, 4x by 2x is 2x. And here we have 2 sine 4x. Now in both the term we have 2 sine 4x as a common factor. So when you take it outside, you are left with cos 2x plus 1. Now we need the answer in terms of cos square x. We know that cos 2x can be written as 2 cos square x minus 1. One of the identity of cos 2x, that is 2 cos square x minus 1 plus 1. So minus 1 plus 1 cancels here. 2 into 2 becomes 4 into cos square x into sine 4x. So that is the RHS of the given identity, hence we proved. So thus by using the trigonometric identities and transformation formulas, we can prove certain results of trigonometric function. We will take up few more problems in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.